Hello, I'm a developer from DENS, and I'm going to talk about what we've done for Milestone 3 in this short video. So we'll talk about three things. What we were supposed to build for Milestone 3, and what we have built for Milestone 3, and finally we'll walk through the test suite to demonstrate how what we have built lines up with what we should have implemented for Milestone 3. So firstly, what were we supposed to build for Milestone 3? We were supposed to build a package that listens to Cardano transactions that are related to DENS and populates a relational database. And to this end, we've implemented DENS query, which does exactly that. It's an HTTP server, which listens to transactions on the Cardano blockchain, then populates a PostgreSQL database. So how do I use this? So in the main repo, we've provided a DENS query CLI flake output, which will provide the DENS query CLI executable, which does what we mentioned. In order to run it, it needs some runtime dependencies, namely a PostgreSQL database running, so that's a relational database, and Ogmios. So Ogmios is the WebSocket connection to a Cardano node. Then once we have all that running, all we have to do is type DENS query CLI in the command line, provided we do have it in our path from the command above, and make sure that we set the environment variable DENS query _config to a path to the configuration file. So the configuration file, it has some pretty basic information in it, namely how do I connect to Ogmios, so it has the Ogmios connection, and how it should connect to the database, namely the Postgres database, and which Unix domain socket that the server is running on. This can also be a host and port, if we want to run over the internet domain instead of the Unix domain. And finally, some specific information about the DENS protocol. Okay, so we've just talked about what DENS query CLI is. Namely, it listens for Cardano transactions and populates a Postgres database. And then we've showed how we can use it. So now we're going to move on to talk about its test suite to show that it does what we intended to do. So moving over to the test suite, we'll talk about an automated test we have over here. So in this automated test, what it's going to do is we're going to spawn all the services. So we recall that DENS query CLI required a Postgres instance running, and this will spawn that for us. It also requires an Ogmios instance running, and this will spawn this for us. And it will also spawn a private Cardano testnet using Plutit that we can submit transactions to. Okay. So then after that, the following lines set up the wallet. It's not super important because this is pretty standard for most protocols. And after that, we get our first DENS protocol. This is the very important transaction to initialize the DENS protocol for everyone. Only one actor should do this at a time. At the beginning, sorry. Then after that, we register a domain. So this user, he wishes to purchase www.google.com, and we'd expect to see some sort of evidence in their database to show that this user has indeed purchased www.google.com. Then after that, the user is going to submit a transaction, which is going to associate www.google.com with the A record, with the IP address 101.1.1.1 and 1000. So this is the time to live. This is the actual content. And after all that, the test suite will complete, and we'll inspect the database to ensure that it has the information that we expect it to have. Okay. So over here, I have the command to run this test suite I just talked about. I'm just going to press enter, let it run. So first see it spins up all the runtime services. So it started Postgres, and then started Plutit. Plutit is the private Cardano testnet. Then set up Ogmios, then it finally set up DENS query CLI. Okay, so the tests have finished. So what we're going to do is we're going to inspect the database to ensure it has the information that we expect. So I'll execute a few commands in here to make sure that we can actually inspect the database. Okay. So in this window over here, I'm now connected to the database that was built after running the test suite. If I do \dt, we can see the schema of the database. So the first thing we want to draw attention to is that if we recall in this transaction over here, we expect to see some sort of evidence of google.com being purchased in the database. So if I do select star from dens_set UTXOs, let me make this bigger, we can see that over here we have this domain name purchased, which shows that google.com has been purchased. So this is hex for google.com. I'll just quickly show this to you guys. So hex to ASCII. You convert. We can see this is www.google.com, and this indeed shows that there's evidence that google.com has been purchased. We can also see that if we make note of then set UTXOs, and we have DENS underscore LMIDs. We can see that this asset class over here, this pointer, is the same as this asset class over here to signify that Google.com has been purchased. And this is the asset class which one can trade in order to change the RRs associated with www.google.com. Okay, so this is further evidence to show that the database has been populated with the correct information. Okay, so after this, they registered the domain. They want to associate www.google.com with the A record with 101, 101, and 1000, right? So to this end, if I do select star from DENS underscore Rs, we can see that we have a type A record as the code, as the transaction submitted, with time to live 1000, as we said before, with the same IP address. And we note that this is DENS LMID 3, so this 3 associates with this 3 over here, and then this 3 associates with this asset class, which is the same as the asset class over here, which associates with this name, which is www.google.com. So this shows that, you know, the RR that we added is associated with a particular token, which this token was associated exactly with the google.com name. So this demonstrates that when we submit transactions to the Canada blockchain, it does indeed populate the PostgreSQL database with the required information about the DENS protocol.